audio not being clear. I hope my audio is clear, though Anirudh, I did also struggle to follow some of what you were saying. The webinar today, as we know, is about energy storage beyond lithium ion, and really looking at options for India. Part of a series of knowledge sharing webinars that WRI-India has been organizing on new and emerging clean energy technologies. The reason we've started this webinar series is, as we all know, India has taken on an ambitious 450 gigawatt renewable energy target by 2030. The previous target, or I should say the current target of 175 gigawatts of renewables by 2022, that too is ambitious. And the reason we say this is ambitious is because we are still learning so much in this space. Not just how to integrate such large volumes of renewables into the grid, but also how do we match the demand and supply of renewable energy, and what is the role really that storage can play in terms of storing these large volumes of renewables when they are generated, then making it available when it is needed to places and consumers where it is needed. We've all heard, I'm sure, many times of how progress on energy storage is going to be an extremely vital piece of the global energy transition, a transition that takes us to a cleaner energy future, one that addresses climate, but also addresses pollution and addresses various other environment and social issues. In India, the energy storage conversations are growing. Pumped hydro, though it's capital intensive and site specific, is arguably the most established energy storage option with close to about 5 gigawatts capacity. More recently fueled largely by the announcements on electric vehicles, and based on the expected demand for electric vehicles, we've seen lithium ion batteries burst on the scene. We've seen consequently a steep decline in prices of lithium ion batteries, though of course they are of smaller capacities, and the electricity discoms, from one of whom we'll hear from today, are still in this sort of testing phase when it comes to lithium ion and their understanding their ability to manage peaks and so on. There's also, as on date, limited lithium ion manufacturing in India, but plans and programs to expand this. And I'm sure Dr. Maithani, good to see you after a long time, but I'm sure Dr. Maithani will also talk about that. But as we think about 450 gigawatts of renewables, clearly it can't be just about more solar PV and more wind, which if you recall, the 175 gigawatts was mostly about solar PV and wind. We have to be looking at more options. And as we think of options, the role of different energy storage technologies becomes critical for us to understand. Not just the big ones, but the other ones that are emerging and gaining credibility, gaining commercial viability in other countries and other contexts. And we have really a galaxy of speakers today from whom we can hear more about these technologies and discuss what India needs to do in order to promote more energy storage systems, including what kind of R&D is needed, what kind of pilots do we need, what will it take us to move from pilots to expansion and scale, and crucially, what kind of policy framework within which should this energy storage systems grow. With that, let me thank you all for joining us this afternoon or this morning, depending on where you are. A special thanks to the speakers and the panelists who've joined us, who represent, as you can see, the Ministry of Renewables, but also the private sector, the experts from the industry, and also from the broader research community. And we look forward to a really useful conversation today. Thank you, and Anirudh, back to you.
You're on mute, Anirudh.
Thanks, Bharat. Now, moving on with our agenda. We'll be having a special address from Dr. P.C. Mehta, who is currently advisor in the Ministry of Renewable Energy, Government of India. Among other responsibility, he currently leads policy and regulation, hydrogen and fuel cell, and energy storage group in the ministry. Dr. Maitani holds a doctorate in physics and MBA from IIM Bangalore, and he has contributed to many papers and articles and authored 2 books. First one being Renewable Energy in the Global Context, and another one, Achieving Universal Energy Access in India, Challenges and Way Forward. Now let me request Dr. P.C. Maitani to give the special address. Sir, you are on mute, sir.
Yeah, it's okay, perhaps. Yeah, thank you, Mr. Jairaj. Thank you. It's really a pleasure to be amongst you, distinguished panelists and their friends, ladies and gentlemen. This is a great pleasure for me to participate in this this event, this seminar, which is really a very contextual. Because since last few years, the focus has always been on if we talk of the advanced storage batteries, then it is always lithium ion. And then things are changing at very fast rate, not only in the national level, but in the globally also. And India is trying to capture the developments which are happening across the world and making a program for the country, which is cost competitive and technologically at par with the global trends. So friends, as Mr. Jairaj has also mentioned in his initial observations, that India has massive plans for increasing the share of renewable energy in the electricity mix. We have set our target of 450 gigawatts by the year 2030. And the initial analysis, which has been done by Central Electricity Authority, suggests that this will require about 27 gigawatt hour of electricity storage capacity, 27 gigawatt and 108 gigawatt hours equivalent of the storage capacity. This is massive from the grid electricity point of view only. At the same time, there are plans for increasing the electric mobility in the country, which also has already started taking off. And the initial observations which were made were that in the new vehicles by 2030, at least 30% will be electric vehicles. But we can see the trends emerging everywhere. In Delhi particularly, you can find the charging stations all across. Ministry of Power has come up with the electric charging policy and plans. Already it is on the ground. And the Department of Heavy Industry is implementing the FAME scheme, which looks for a massive ecosystem for electric vehicles. These all are contingent upon how storage systems evolve over the period of time. Apart from that, the third dimension is that the storage cannot be defined in terms of batteries. It is beyond that now. And many of the storage technologies which were in vogue, particularly the pump hydro and others, are also attracting interest of the policymakers in a big way. And Ministry, if to my latest knowledge, Ministry of Power has constituted a group to relook on the pump hydro storage potential in the country and see that under the changing circumstances, how they become more cost effective. So the first point is that India is committed for increasing the share of renewable energy in the mix. And we have undertaken the programs, plans for rapid adoption of electric mobility. Now, another thing in the electricity mix, as I mentioned, that the electricity authority, Central Electricity Authority has come up with some numbers, but it is fact that the more we increase wind and solar in our electricity mix, the challenge remains for the integration of the grids. And same time, the electric vehicles also, the costs are prohibitive, and access to affordable high performance storage technology is likely to be key for unlocking the full potential for both these sectors. So this is the background which I thought that, and In this, the main component is again we say that electricity energy storage is the main component for the electric vehicles. So low cost, high performance storage systems is crucial. And whereas lithium ion batteries have been dominant technology so far for mobile application, increasingly grid connected storage over the recent years is the viable option, is only coming the alternate battery storage technologies. And it can be stored in various forms, including thermal, chemical, and mechanical mode. Now the point comes that if it is so, then is there any ecosystem which really looks for the country under this dispensation for the new, which have been trying under the Niti Aayog's, this National Mission on Transformative Mobility and Battery Storage, and that has piloted a scheme which is technology agnostic. So the main challenge remains the technological challenge, because these storage technologies are at various stages of development, vastly differ in terms of performance capabilities, longevity, and cost. And the choice of technology which India should take, and for a particular application and market scenario, it depends on the technical compatibility, requirement, and manufacturability, and cost competitiveness. So now this mission, as I said, is the technology agnostic. It focuses on the performance parameters like cycle life, energy density, and the main aim, the government of India's this policy whereby 18,100 crores rupees have been earmarked for this. This is a massive number if you look from the India's perspective. Then you'll find that there is a wish and will at the government of India level to create an ecosystem for advanced storage technologies in a bigger way. So it is not something which we are looking for the lithium ion battery or lithium ion technologies, which is much beyond that, and none of the policies at the government level looks for only lithium ion battery technologies. Second point is that lithium ion batteries require relatively rare materials input. Recent development which have taken place in the area of sodium sulfur, zinc air batteries have significantly reduced dependency of these rare materials, and they have potential to achieve high performance with abundantly available material. That is one of the things. Another candidate technology which we are finding that in India, some startup groups have also started working on that, is the Aluminium Air Battery, and it has shown significant promise, and it offers higher energy density, but there are issues related to stabilization and its safety standard, and other parameters are also under experimentation at present. But certainly a lot of promise this technology is promising to us. Redox flow batteries is the another application. If you go with the Chinese development which have taken this redox batteries, we'll find that they have focused particularly for grid applications and other applications, stationary applications. Redox batteries are being seen as major candidate technology in lieu of the lithium ion batteries, and they have no performance degradation virtually for over 25 years. We can just continue with that, and the discharge capability is up to 100%. That makes an ideal candidate for supporting renewable power integration. So friends, these are major technologies insofar as batteries are concerned, and pump hydro is a viable option, as I said my initial observations. And now some of the projects which are coming up, particularly I don't want I don't want to quote the name of the company or other, but they have come up, they have submitted proposals to government that wind solar power generated can be stored through pumping water, and that can be used for again providing the steady power. So, and they are looking for, can our regulations and policies provide some kind of incentive regime whereby such kind of pump hydro projects, which are primarily based on the variable renewable energy, can work. I personally feel that it has a lot of potential, and such options needs to be looked into, particularly from the cost competitive perspective, whether these are the better options from the advanced chemistry batteries, or they are even there. If they are competitive and locations are available at different places, why not we can see these options in a bigger way. And such options can not only provide the grid security, but also provide the grid ancillary services. That is another thing which we look for. Hydrogen is as a new buzzword, and a lot of enthusiasm all across for hydrogen is also there. Hydrogen is also seen as a storage technology. And since last 2-3 years, about 17 plus major economies have come up with their plans for hydrogen energy. India has also been in a process. We have announced a national hydrogen energy mission, and we are in the interministerial consultation process at present. This mission looks to develop a hydrogen ecosystem in the country in a big way, and particularly for all three applications: for renewable energy integration, for mobility purposes, as well as for replacing fossil fuel in the hard-to-abate industries, particularly steel, fertilizer, and petroleum refining, which are the main users of this thing, and where it can make a major difference insofar as the abatement of the CO2 is concerned. So hydrogen, our present analysis suggests that electricity storage-wise, hydrogen may perhaps not be a better option unless we go for a long duration storage, which is more than 30 hours or so. Cost does not permit that. Batteries are the better option as of now. But in transportation also, the analysis suggests that for short duration transportation, batteries are better option. For heavy load, heavy duty, or long duration, long distance transport, hydrogen can offer a better option for that. So a lot of activities are undergoing. We have started working on some of the demonstration of hydrogen-based transport system, particularly in some pristine location in Himalaya and some island also. One of the islands, when we found that the diesel-based electricity generation is ranging 25 to 30 rupees per unit of electricity in that island, then another proposal has been developed: can it be replaced by the hydrogen-based electricity system, and which the initial analysis suggests that can be cost competitive, and the cost of and there will not be any additional flow of government money if we replace diesel by the hydrogen-based electricity generation system. In industries also, government has plans to come up with some kind of mandates for some of the industries, whereby green hydrogen can be used in these industries, and in a progressive manner, in a gradual manner, the utilization of fossil fuel can be reduced over the period. So this is another option, which is alternate to lithium in many ways also, and we really are looking forward. Within next 2 years, we hope that something will really move in a big way. So finally, I would like to say that energy storage is certainly very, very crucial for realizing full potential of renewable energy, and it is for innovation. What is imperative is that to promote innovative concepts and new technologies in this field. So our policies are largely technology agnostic, and the relevant energy options will continue to be supported depending upon technical compatibility, end-use application, best indigenization potential, cost competitiveness, and efficient utilization of available resources. Here comes the role of resources, very, very important, which are nationally available. There are a number of reports which are coming that the cost of raw material is increasing, shooting very high, particularly in the lithium, in cobalt, and other technologies, other material which are used for storage. We have already made a beginning in the energy storage for mainstreaming it in the electricity sector. The recent tenders which have come from Solar Energy Corporation of India have been looking for the hybridization of renewable energy, as well as dovetailing it with the storage capacity, so that we can meet the energy requirement beyond the availability hours, particularly for peak hours or those hours which are not, where renewable energy is not available. So in brief, this is an area of focus. It is something which is really moving in a big way. Our all knowledge, which was yesterday, is dated today, and we progressively are looking for a regime whereby within next 2-3 years, we will be having these technologies which are dependent not on the resources which are not available in the country, but primarily dependent on the national resources, and we will be in a position to acclimatize these technologies, as well as create an ecosystem for manufacturing and large-scale deployment of these technologies. I'm sure that today's webinar will generate new ideas and discussion in the most effective energy storage solutions for various applications. And with these words, I would like to thank the organizers for inviting me for this very pertinent and contextual event. And I look forward to engaging the insightful discussion in the session to follow. Thank you very much.
Thank you, Dr. Mehta. It was very insightful. Thanks for the special address. Forward with that. Following the special address, we'll be moving to presentation segment. For the first presentation, we are having Dr. Tejas Kusaka, co-founder and CEO of Off-Grid Energy Labs, to explain about their technology, zinc gel batteries. A few words about Dr. Tejas Kusaka. He comes from a diverse background ranging from biotechnology to materials. He has hands-on experience for about 8 years on various sustainable energy technologies. And, this all started with his PhD journey at IIT Kanpur. So, I request Dr. Tejas Kusaka to share his presentation.
Sure. Thanks, Anirudh.
Yes. Yes.
Okay, so I hope the screen is visible.
Yes.
Great. So indeed, I'm delighted to be on the panel today. Hope everyone is safe and getting vaccinated. So COVID has taught us many lessons. One of the most interesting lesson is that ventilators are not important everywhere, but and that they are not for everyone. So only serious patients need ventilators. Rather, oxygen concentrators help curb second wave of COVID. We all know that. Energy storage industry also is actually learning from this lesson. Alternative chemistries can curb the massive wave for requirement of energy storage, and in some cases play a critical role as well. At Off-Grid, we're exactly doing that. We are an IP-led battery tech company focused on innovating around three key vectors: chemistry, materials, and design. Our mission is to accelerate energy transition using our batteries that are commercially viable and, most importantly, sustainable. Batteries have existed since 150 years, but there were tremendous development in past couple of decades. One of the biggest challenges even today is mismatch between performance, cost, and sustainability. Technologies that are affordable are inefficient, while others with better efficiency are expensive or unsafe. In most of the cases, batteries use unsustainable and geopolitical dependent materials. Now, on the one hand, we are transitioning toward cleaner renewable, but on the other hand, we are storing that clean energy into toxic and non-sustainable batteries. Therefore, there is a need to build energy technologies that solve critical problems of particular applications rather than one battery solving problems in general. We have actually invented zinc gel technology that uses zinc, the known abundant material used in battery since very long time. Invented a new electrolyte that does not evaporate or catch fire. And the most interesting part about zinc gel is that we can tweak the performance parameters like energy density, fast charging, or thermal stability to achieve better version for a specific application in stationary or in mobility sector. So what does zinc gel technology has to offer? Zinc gel can actually offer battery powered fast EV chargers for faster, cleaner, and safer EV charging, renewable energy storage in commercially viable manner, powering low power electric vehicles that solve a critical last mile problem, and energy storage for power utilities for peak shaving and grid balancing applications. Now, we have been operating in stealth mode since last 3 years. And recently we have completed third-party validation of zinc gel battery by global certifying and testing agency. We have established partnerships right from validation to manufacturing to deployment. Now we are in the phase of finalizing the process and design for manufacturing of this battery, and we expect to be ready for commercial launch by the end of year 2022. Feel free to reach out. Thank you. Back to you, Anirudh.
Thanks, Tejas. Thanks for the presentation. Let me just request Tejas to stop sharing the screen. Yeah, thanks. So moving forward, we are having presentation from Dr. Saurabh Timberlake. Little intro about Dr. Saurabh Timberlake. He is the CEO and co-founder of SOH High Tech, Switzerland-based clean tech startup. He's a leader and strategist in the field of sustainable fuels and power. He did his bachelor's in electrical engineering with a master's in microelectronics from IIT Bombay. Later, he obtained his PhD in solar fuels from EPFL. Saurav invented a groundbreaking solar fuels production technology and is currently leading the commercialization of this technology via SOH High Tech. So let me now request Dr. Saurav Tembarne to share his presentation with us. Dr. Saurav.
Thanks, Anirudh. Let me start sharing my screen. Okay. I hope you guys are able to see the screen.
Yes, sir.
Okay, perfect. Yeah, thanks for giving me the opportunity to basically present what we do and briefly talk about hydrogen storage in this quite interesting webinar. So basically we are a company based out of Lausanne in Switzerland, and essentially we are a caterer for solar fuel and power solutions. So let's see what's the main problem we are trying to solve here. Hydrogen is deemed to be the fuel for the future, though the main problem is that most of this hydrogen in fact currently is produced from fossil fuels itself, and most of this is done in centralized facilities, and this is multiple issues. So what's our solution to this? Basically our idea is to provide an on-site system much like trees. So basically, in fact, our product is like an artificial tree, which uses sunlight and water as the only input resources, and which can give you a highly clean and pure fuel, that being hydrogen, but it can also co-produce oxygen and heat. So essentially what we provide is a cost-effective system for on-site production of cleaner and greener fuel as well as power. So here you can see actually how our artificial tree or ARB looks like. So essentially how it functions is basically it functions with concentrated sunlight, which is getting concentrated in the central spot. That's where the key innovation from our side is put. Basically, it's a small device which is absorbing this concentrated sunlight, and it's doing photo-driven electrolysis of water. And this we do thanks to our technology, basically at very high efficiency. In fact, we have demonstrated almost twice efficiency than any other conventional solar based hydrogen production approach. And this we do on top of the efficiency, basically at high throughput, which is also important. So basically the production output per meter square of land area is also very high with our solution. So that's in a nutshell basically our technology. Briefly talking about now basically the hydrogen and how it plays a key role in energy storage. So as you already know, India has aimed, or India is planning to increase its share of variable renewables to almost 30% by 2030. This is a positive step in the right direction, though it's also going to create multiple challenges, and their challenges being related to the energy storage, because from variable renewables, the production is always variable. One ideal way to store this energy is by converting it to chemical fuels such as hydrogen. So basically this excess electricity can be used to convert water into hydrogen. Now, why hydrogen makes so much sense for energy storage? So on the left side, basically what we are doing is we are comparing various fuel in terms of their specific energy densities. And you can see that hydrogen lies on the right far axis of this very particular plot. What it means is hydrogen has the highest gravimetric energy density. So basically per kilogram of hydrogen, you can release the highest amount of energy. So, and then also on the scale as well as time wise, on the right plot, you can see that hydrogen is an ideal candidate to do large scale storage and do storage for long term compared to various other technologies. But so from this perspective, hydrogen is a very ideal candidate for energy storage. But what are the key challenges? The key challenges currently are in fact related to the deployability as well as cost. So on the left side, you can see that we are basically presenting what's the current price of hydrogen production coming from grid-based electrolysis. And currently we are somewhere here, which is about $5 per kilogram. Though, in order for hydrogen to compete with gray hydrogen, which is coming from fossil fuels, the price has to be all the way down to $1.5 per kilogram. So there is a long way for us to go from basically current price to a competing price for green hydrogen. And on the right side, we are comparing basically various grid scale storage solutions based on the cost of discharge electricity, but also based on basically long-term or short-term storage. So basically higher the number of cycles of uses, this corresponds to short-term storage. And here technically lithium ion batteries have been leading leading the route here, and currently with the current status, hydrogen is somewhere here. So currently it's not competitive at all for short-term storage. But in future, if the price of green hydrogen production comes down, then you can see that hydrogen can become, and in fact even beat the batteries and even other competing storage solutions, even for short-term energy storage. Though discussing about the long-term energy storage, you can see that for the red plot shown over here for hydrogen current status, as well as the dash plot for the future status, hydrogen can already be competitive for long-term energy storage solution. So that is something to take away from this, and basically we can already start working towards this storage mechanism for doing long-term storage. In terms of a brief overview about how hydrogen is stored, so basically there are multiple options. For small to mid-scale storage, you can store it in cylinders, liquefy hydrogen, or do basically metal hydride based hydrogen storage. But this is viable only for short scale of storage. For large scale storage, in fact, this has to be done in terms of underground hydrogen storage, much like how oil currently is stored underground, not stored really, but it's being there or being produced there since ages. So basically storing hydrogen in salt caverns as well as depleted oil gas fields would be the way to go forward if you want to do large scale hydrogen storage solution on basically a practical scale, as well as make it economically competitive. So that's about hydrogen storage, but where does our solution comes into picture in this scenario? So basically, as I briefly highlighted, our solution is a solar hydrogen production system, but there's an added benefit with our solution is that it's a hybrid system which can work with sunlight as well as grid in complete synergies. What it means is solar light is always dynamic. Whenever you don't have peak sunlight, you can take grid electricity input and continue to produce a constant output from the system and basically store the excess energy, which normally leads to either grid instability or curtailment of this renewable energy power. So that's the solution in a nutshell. The way we scale up is basically you can imagine big forest of these artificial trees, which would act as your power and fuel production plants. And to end my presentation, I would briefly like to point out that basically why we are so competitive compared to all other various ways of hydrogen production. So here is a brief chart showing basically sustainability and the production price of hydrogen, comparing all the various ways of doing hydrogen production. And you can see that our solution is not only the most sustainable option out there, but it can also be the most competitive one or economically competitive one. And when I say competitive, the production price of hydrogen which we are talking about is about $1 to $2 per kilogram. This is what has been targeted by various basically renewable energies for making hydrogen into an economically interesting and viable solution. So with this, yes, I would conclude, and thanks a lot for listening.
Thank you, Dr. Saurabh. Very interesting presentation, and also for comparing your technology to Indian topology, we have many regions which have very good solar potential, and that a lot of states have good normal irradiance. So I hope we can have the similar kind of technology penetration in our Indian states. With that being said, let me. So following on the presentation, we now have Dr. Nilesh King. Brief intro about Dr. Nilesh King. He is currently working as the Chief Distribution Mumbai Operations for Tata Power. Dr. Nilesh King has over 26 years of experience in power sector in the field of operations and technology, ranging from conventional to non-conventional sources of energy, battery storage system, reactive power management. He's also a member in various committees such as BIS. He's a B certified engineer, energy auditor. He's also associated with the power sector reforms in Tata Power Delhi Distribution Limited, and is involved in most of the technology adoption in power distributions in Delhi. Now I request Dr. Nilesh to share his presentation on utility perspective of storage.
Thank you. I'm just loading my presentation. Is it visible?
Yes, Dr. Anish, it's visible.
So thank you, Aniruddha, and thank you, organizers for inviting for this conference. From utility point of view, I am sharing our experience and our expectation from the different battery energy sources. Beyond lithium ion is very important question, and rather we should answer that to scale the battery storage in time to come. So our experience, let me go through our experience. Rather, we started a lot of pilot battery energy storage adoption in Delhi. And these are few pictures, we have adopted 2 years back 10 megawatt hour lithium ion battery storage in Rohini in Delhi. And we are using since last 2 years. This is to demonstrate the application of, the battery storage at the utility level. The second picture, that is also one pilot scale, that is a KW scale battery energy storage. Here also we have used NMC lithium ion battery, and especially we have done this in community battery storage, and we have used this at the distribution transformer end, to maximize the use and get the best of the reliability and peak load management other applications. From the utility point of view, we have longer feeders, and the reactive management, and the voltage profile management, and all other applications. So we did a small pilot of
interrupt you for a minute. There is a request to put it on the full screen. Your presentation.
Pardon?
If you could put it on the slideshow full screen. Yeah, I think.
Is it now?
No, not yet. The fourth button from the left button.
Is it visible now?
Oh yeah. Oh, okay. Yeah. Please go ahead. Please go ahead.
Is it okay now? Yeah.
Yes, sir. Please.
Yes, sir. Please proceed, sir.
Okay. And the last one is the pole mounted battery storage. It's 20 kilowatt small capacity battery storage is being used on a longer feeder at the fag end, especially to take care of the peak load requirement, as well as taking care of the voltage profile management and reactive management. So this is in a nutshell experience of our battery energy storage so far as. And one more vanadium based flow battery also we did a pilot. So these 3-4 pilots we did. So this is just an experience on power distribution utility. So these are the applications, from the utility scale point of view. We are in a generation, we are in a distribution, as well as in a transmission, and we look forward for various applications like frequency regulation, ancillary market, ramping, and all. In addition to that, capex deferral is very important application. We are looking forward, and to some extent, the pilot, we got in the experience of using that for energy arbitrage and capex deferral, transmission distribution, congestion relief, and all. Solar, obviously, we are in solar too, and for reduced RE curtailment and capacity farming, we look forward to use the battery. Mini grids, we have rolled out more than 100 microgrids in the villages of Bihar and Uttar Pradesh. So there also we looking forward for some battery storage application, and obviously everywhere the requirement and the specifications of the battery are different. So we look forward for different applications for the battery and the different technologies of the battery. So this is our expectation and the desired chart from, because we are in generation, we are in distribution, we are doing microgrid applications, we are in mobility too. And behind the meter is another application which is evolving, especially where time of day tariff is very extensive, and the customers are very choosy to optimize their electricity bill. So these 6-7 parameters on which we are expecting different battery applications. Round trip efficiency, obviously we want best of the round trip efficiency. C rating is also very important, either for the energy or for the power application. Energy density is also very important for specific applications, especially for the mobility application. Low weight battery solutions are desired. Ramping rate is also important in most of the application. Depth of discharge. We have listed down, these different characteristics and the expectation of the battery from the point of view, because we did an extensive exercise of testing the battery, different types of the battery. Number of cycles, that is also very important, the life cycle of the battery. and tolerance to the temperature. Reason behind many batteries require, air conditioning and many do not. So auxiliary power consumption is also a very important parameter when, going to select the type of application or the type of chemistry or the type of solution available so far as the battery is concerned. So this is a simple chart based on which we generally select the battery, or rather these are the expectation from user like Tata Power. Rather, we started our journey, developing the battery test bed with the ITT. So we have developed the battery test bed, a small microgrid, and a setup where we have tested different batteries, right from 2 kilowatt capacity to 10 kilowatt capacity. So different different chemistries of the battery. We got samples from overseas as well as from the Indian suppliers, and then we developed our test set where we did a very extensive testing of the battery and got some very very good results from that test set to decide on which battery or which chemistry is suitable for different applications. So these are, there are many batteries we tested, but these are the 4 batteries we tested in our test lab. One is the aqueous sodium ion battery, the lead acid battery, lithium ion NMC and LFP batteries, and then the advanced lead acid battery, that is the lead acid with, the supercapacitor. So these are the batteries we tested in our test lab, and more samples we are receiving and we are testing in our laboratory in Delhi. So we did, more than 6 months, the complete testing of the batteries we carried out, and the extensive testing of the battery for performance assessment we carried out. And the major parameters, one is the depth of discharge, energy output, tolerance to high temperature, because in an Indian environment, not necessarily all batteries are, the suitable. So tolerance to high temperature, accelerated aging test in which few batteries not withstand or sustain, power output, and the mini grid simulation, because we have urban and the rural microgrid simulation setup was also there. So on these 5-6 parameters we tested the batteries, and these are the few the graphs and the pictures indicating the result of the battery testing lab in the the Rohini. And these are the algorithm, the partial state of charge condition, and these are based on the IS and IEC. We have developed our own testing protocol, and based on that, we have carried out the extensive testing of all the batteries, and then we did the comparison of the performance as per the technical specification given. And based on that, we have come out with some internal decision making that which chemistry or which battery is suitable for which application in a limited source of availability of the different chemistries. So these are the key findings, for aqueous battery. The performance in terms of, the deep discharge and ability to provide energy output are very favorable, but the performance degradation observed, over a period of time. So in an accelerating aging test, the results were not so favorable. Lead acid battery, everybody knows, the thermal runaway and limited depth of discharge was an issue. Advanced lead acid battery, we found, it is a balanced solution from the economics point of view and the technical specification point of view. It was a very successful and satisfactory meeting most of the testing criteria, and the cost was also well within the range. It is a balancing between, the lithium ion and the lead acid. And obviously NMC LFP we tested for, the different parameters, and the lithium ion performance, obviously it was very good. Due to its best of the C rate, best of the ramping rate, and all other parameters, it was fantastic in accelerated life test. The only thing is that tolerance to temperature and the auxiliary air conditioning required for this battery to maintain was little high as compared to our expectations. So these are the few findings and recommendations. Continuous load requirement. So this is the vanadium based battery, a small pilot we did, vanadium redox flow battery. We did in Delhi for, our street light load, which is generally called a constant or a very uniform load. So there we carried out that, and we carried out all, the parameter testing also. We found round trip efficiency around 70%, the best of depth of discharge of 90%, and life cycle is fantastic. So far as the vanadium is one. Auxiliary consumption is very low, and the battery can be recoverable. So based on these different results, we have recommended that the flow batteries we are trying in microgrid applications, and along with the advanced lead acid, we are proposing the flow batteries can also be used for the applications in microgrid where comparatively constant uniform load is there. So this is what the limited experience from the utility side. The best of the presentation done for the new chemistries and the new technologies are available. So we look forward to implement that in our our requirements in Tata Power. Thank you.
Thank you, Dr. Nilesh, for this detailed presentation. And we have some couple of questions for the presentation panel. And let me just first question is to Dr. Tejas. The question is, how does off-grid energy's zinc gel battery compare with current lithium-ion batteries on the market in terms of cost per kilowatt hour and energy density? And how likely it's going to evolve in the future? I guess this question will also be discussed in panel. A little short answer should be fine.
Sure. So as I explained, zinc gel is not just a single battery. So we have built zinc gel as a platform. So we can actually tweak the individual components of this technology, such as electrolyte, cathode material, assembly, and make the version that is best for that application. For example, with respect to energy density, we can go right from 20 watt hour to 80 watt hour per kg. For C rating as well, we can achieve up to 5C current rating. So basis the application, we can actually tweak the components of this. I hope I answered that question, but it depends on the application again. And with respect to cost, we are quite certain that we'll break the 100 USD barrier.
Thanks,
even in next 2 years.
Good to know. Thanks, Dr. Tejas. And since we are running behind the schedule, I request Dr. Nilesh to answer some questions in the question and answer chat box. There has been many questions regarding the test kit, battery test. So please request Mr. Nilesh to answer those questions when possible. And we are moving ahead with the schedule here. Now that the presentation segment is over, we are moving to panel discussion. And again, Dr. Maithani, who gave the special address, he will also be joining us for the panel discussion along with Dr. Tejas Kosarkar and Dr. Nilesh Kane. And there are other panelists who will be joining the discussion. One is Dr. N. Silvi. She is the Director, Central Electrochemical Research Institute, CSIRC. She has over 25 years of research experience contributing to several journals and articles with specialization in electrochemistry, energy, nanomaterials, and organic chemistry. She has countless recognitions for her work in the research field, including Top 100 Scientist of the Year and International Scientist of the Year, 2007. She is also in the review panel and editorial board for several journals. And she is also the editor of a Tamil scientific publication called Ariga Arivial since 2011. Thank you, ma'am. Thanks for participating in the panel discussion. Next is Mr. Devi Prasad Dash. Is currently the Executive Director, India Energy Storage Alliance with Customized Energy Solutions. He has been involved in techno-commercial feasibility and consulting in emerging technology areas, ranging from energy storage to EV infrastructure. He is also part of BAS energy storage standards as well, and takes active role in policy advocacy to both central and state governments in India. We are glad to have you in the discussion, Mr. Devi Prasad Dash. And finally, we are having Veronica Garcia, who is the founder of BitLumens. Veronica Garcia is an investment consultant at Credit Suisse and UBS for Latin American asset managers. Her research is focused on renewable technologies and on quantifying the investment needs to reach the country targets for renewable power generation. In 2018, she founded Lumens, which facilitates scaling of renewable technologies in developing countries using Internet of Things and blockchain technology. We are glad to have you in the panel discussion. The panel discussion will be moderated by my colleague, Mr. Deepak Krishnan. He is the Associate Director for WRI-India's Energy Program, and he leads the work on clean energy initiatives for different consumer categories, clean energy transition, and water energy nexus. He is also a certified energy risk professional. Prior to this, he worked with the energy consulting practices PricewaterhouseCoopers and Deloitte. So without wasting further time, let me give the control to Deepak.
Thanks, Anirudh, and if you could, and my request is if it's feasible to all the panelists to please switch on your video, only if it's feasible and you're comfortable doing so. So thank you very much for joining us today, and we are at 3:55, and let's all try to wrap this up by about 4:20, so that this comes some time for Q&A. I would like to start off with a set of questions to Mr. Devi Prasad Das. So you heard Dr. Maithani speak about the fact that the MNRE's focus has been or is technology agnostic, and the ultimate goal of meeting the requirements of the industry is what matters, be it the power sector, the industry segment, or transport. So in that context, which are the top, even though you say technology agnostic, you still do need to make some of those big bets, given that, control over supply chain, leadership in, establishing those industry presence in the country is also important. Case in point, China and solar, both are spoken about in the same breath. So which are the top 3 technologies that you feel the government should place its bets on? And a follow-up question would be, what kind of policy support do you further expect from the government for the sector? And are there, 1 or 2 foreign policies that you think India should consider adopting to improve the capacity for emerging technologies in storage?
Okay, thanks, Deepak. I hope everyone able to hear me. So the first answer is government should not force any policy, any technology. They should be technology agnostic. Let market decide the technology, because if it's in Europe or US or any other market, it depends upon the market mechanism. Just government should give a platform where it should be technology agnostic, so that whichever the technology is suitable, irrespective of it is mechanical or it is maybe electrochemical or fuel cell, it should grow. If giving example of last 8 weeks, what is happening in the Ministry of Power, and it's very much actually positive for the industry, including draft ancillary services, draft NEP, recently the ISTS, whatever. So the great step by Ministry of Power is really incentivizing the energy storage industry, which was not done 3 years back when they have limited to the thermal plants for the ancillary services. So we have learned in a long way, but we should not now tell about this technology only suitable for this application. That's the first point. Second point about raw material. If raw material is the main bottleneck, then all gigafactories should be in Argentina, Bolivia, Chile, or Afghanistan. We should not see the plants in America or now in emerging Europe and other countries. So we should not think about the 20% of the raw material, cobalt or lithium. We should focus on how we can address that, maybe urban mining and other things. But we have manganese, we have nickel, we have LFP batteries can be done, we have iron. So we should focus on that. And it's not about lithium. It's about any technology. It's maybe zinc-based batteries, it may be aluminum-based batteries, it may be sodium-based batteries. Irrespective of technology, both state and central government just give a market mechanism. That's the only expectation from industry for last 9 years. If that is done, industry will flourish like any other emerging countries. And regarding price point, yes, price point is bottleneck for all technologies, irrespective of it is energy or it is semiconductor, it is a solar or it is a mobile phone. That market will find a reason how the price fall will happen over time. So government will should not think about this price is the bottleneck. Only thing is market mechanism. That is from first to end, just give a platform or give a field, appropriate players will be evolved over time.
Okay, so, but if I may just probe a little on what you said. So, Dr. Mehtani did mention that the government is committed to be technology agnostic. So, and your point about, creating the market for various technologies which are at a comparable commercially competitive scale is what you need. But, there is also, a great advantage in, providing the public support for, public money support for R&D in very promising technologies. So are there those, two or three which right now may not be in the same commercially competitive league that you are referring to, but, something for the future where, the domestic industry capabilities can be built, and we could also, be a sort of a center of the industry for the rest of the world.
Yes, Deepakji, you raised a good question. Actually, Dr. Kalai Selvi will mention it in her speech, but this is actually good part. We should not run behind what are the technologies available in our nearby countries or in the developed countries. We should think about next 8 years. And that was the reason when we worked with Niti Aayog and DHI, we pushed for that niche SEC, which was already approved for 5 gigawatt of manufacturing, which may not be in gigafactories. Now we just heard from Reliance News, just it is going parallel. They are going up for the gigafactories and batteries. So we should also incentivize solid state batteries, lithium sulfur, lithium air. So new emerging chemistries, maybe in the sodium ion, something which is more safe and also higher energy density, maybe for aerospace application or urban mobility. So these are the new emerging applications are coming, or medical applications. So Indian government did the first step, which is really appreciable, going for the niche chemistries SEC program for the PLI. But beyond that, also we should also create the application side demand. Like now all the tenders which is coming from the central tendering authorities or something are short duration applications. You will not find appropriate tenders for a long duration applications for 8 hours or 7 hours. But we should not think only about short duration. We should think about other application areas or other new emerging applications, because in batteries there are more than 21 applications, from mobility to power electronics to renewable to grid. So there are multiple areas and multiple sectors. Also, all other bodies focus on demand side incentives for new technologies. Maybe that is required for the short term. It is not required for next 10 years or 15 years. Maybe for next 3 to 5 years, we should focus on that, so that the national R&D institutions or the new emerging startups who are working on the new technology, Tejas we know very well. So they are doing this, Log9 is doing good work. There are other companies working on mechanical storage like compressed air or like flywheel, or they are working on the bricks taking some height and then other type of mechanical storage. They should also get a chance for the pilot and demonstration. Lithium ion and other don't need a demonstration now. If you're doing a lithium ion demonstration, we are actually taking the industry 10 years back. We should give the chance for the demonstration pilot to the newer technologies. Pumped hydro, we discussed a lot, but across the globe, the least installed new project is pumped hydro. Yes, it is taken 90% of the market till date, but now whichever the new storage project is coming is not pumped hydro. So why you around 90% of the time are on pumped hydro? Whichever is there in India, it is not active. 50% of them is not operationally, so is not operational now. So let's think about new technologies. Let's discuss about how pilot and demonstrations can happen. So Dr. Kalai Selvi might mention about this thing, how CCRI is working. And actually Mehtani sir is actively working in this space, and his guidance actually gave National Energy Storage Mission 3 years back. And we appreciate sir's effort.
Thank you, Devi. And so that's a nice segue to actually pass on to Dr. Kalai Selvi. So Dr. Kalai Selvi, we heard Devi speak about the need to invest in emerging, storage technology. So given the, the research that you are leading at CCRI, and based on what you are observing from, studies of publications, peer reviews, what do you think are some of the future technologies that the country should focus on?
Yeah, Namaskar, and thanks for the opportunity. So I just wish to go one by one. First of all, we are Central Electrochemical Research Institute, concentrating only on electrochemistry-based energy storage technologies. So I'll be talking about only electrochemical energy storage. And we do work on a number of battery systems, as rightly pointed out by Devi Prasad. We are having a kind of a track record in lithium ion battery. He was talking about a demonstration. Dr. Devi, I'm so happy to inform you that just 2 days back, we transferred the technology on, technology transfer is still ongoing to Tata Chemicals, Mumbai. And the team is there with our Chennai center. So our indigenous lithium-ion battery technology is now transferred to Tata Chemicals, Mumbai. So the technology demonstration, that to homegrown technology transformation is now taking place. So this is one good thing I just wanted to share with all of you. That is number one. And when you are talking about this lithium ion and its infrastructure, especially in terms of supply chain, yes, we from CICRI, to some extent, ISA also knows that we already conducted 2 types of industry meet wherein we identified indigenous supply chain partners. So now that we are so confident that starting from raw material, for every component which is required for lithium-ion battery, we have indigenous supply chain partner, except for that case separator. So everywhere we have this kind of an indigenous supply chain partner. Therefore, we are hopeful of just meeting out the cost requirements also. This is about lithium battery, and he was worried about even the lithium availability. So I used to say that people need not worry about the lithium availability, because right now, how many mobile phones and lithium-based resources are available in the country? If we are able to effectively recycle or refurbish those spent batteries, and if we are able to give them a second life, I think that will really address 30% of our futuristic requirements. This is one thing. So therefore, lithium need not be considered as a great hurdle. We need not worry about cobalt, nickel, and manganese, because from the spent batteries, we will be able to again go with another 30%. We will be able to fulfill the 30% of the futuristic requirement. Now, coming to the other thing, you talked about even metal air. Dr. Maitani also talked about 2-3 things. Hydrogen also. Sir, we are also working in green hydrogen generation, and especially electrochemical way of generating hydrogen. And somebody was talking about this hydrogen-based mobility was demonstrated somewhere else. Actually, we from CSIR, 3 labs like NCL Pune, CICRI Karaikudi, and NPL Delhi. These 3 labs together, along with a private company, we demonstrated a car, hydrogen-powered car. That roadshow was also demonstrated just a few months back. So we are there in that case of hydrogen generation as well as hydrogen storage also. One of our CSIR labs called the CMERA, they have developed the Type 4 tank also for hydrogen storage. This is with respect to that. Now coming back to again batteries, today you are talking about beyond lithium. My first choice will be sodium battery. So I just want to touch upon Dr. Maitani's words, because when we talk, if you just take the market, I just view it from 3 different angles. One is consumer market, other one is the EV driven, that is the electric vehicle or the mobility market, and the last one is what we are talking about, the grid level storage. So for a consumer market, this sodium ion battery could be definitely recommended. And we from CSRC3, we have patents for sodium ion battery cathode, anode, electrolyte for every part. So soon, within another 1 year, we'll be coming up with indigenous sodium ion battery technology also. So this could be really considered for consumer electronics, and lithium battery for another 1 decade or at least for another 6 or 7 years. This could be considered for EV applications. Definitely, India can really come up with the indigenous lithium battery technology, which will be finding its application for e-mobility. And the third one, which we're talking about, is the large scale, mega scale, and the grid storage. There, from CICRI, we are also working on redox flow batteries. From Tata Power, I think Nilesh Kani was talking about vanadium redox flow battery. Yes, we are also working on vanadium redox flow battery. We are working on metal redox flow battery, metal halide redox flow battery, and especially our zinc bromine and all vanadium redox flow battery will only be able to satisfy our requirements with respect to the grid level storage. So these are my comments and my observation. And we from CSIR family, and especially from Central Electrochemical Research Institute, Karaikudi, we have technologies in the developed stage for lithium battery. Within next 1 year, we'll be coming up with the technology on sodium ion battery, whereas our TRL level in redox flow battery is somewhere around 3 to 4 only. So this is what I just wanted to make a mention.
Thank you, Dr. Kalistri. So based on this and given Dr. Maitani's time constraint, wanted to request Dr. Maitani if you want to respond to anything that Dr. Kalistri and Mr. Das mentioned. In addition, one particular question that we had is, what are your thoughts on bringing in storage purchase obligation? We may name it differently, but the way solar purchase obligations have helped the industry in bringing down costs, is there scope for similar things in the storage?
Thank you. Thank you, Deepak, for this. But first of all, it is learning to me, and I got a lot of new insights about that. And the observations made by Madam Dr. Kalai Selvi and Devi Prasad were really very, very pertinent. No two opinion, number one. And we are fully convinced that there should be no prescription from the government on the technology. That will go against the market principles, and otherwise it will also not work. But at the same time, it's very important that the information asymmetry does not remain there, that the consumer has right choice. They know that what is the best candidate technology to be utilized for what kind of application. That is very, very important. So in the importance of understanding that what technology can provide what is very, very important, even though there is no prescription or no kind of judgment that this is better or this is wrong. Maybe they can take their own choices. But end of the day, what will matter? That what are the specific requirements of a particular application that needs to be catered? Here, Madam has mentioned about the Redox batteries, that China is looking big way for the grid integration. That cannot work for the mobile application where mobility is involved. We know it very well. The stationary cells are entirely different that of the mobile applications, because their requirement size may not matter there, but size matters in the mobile application. We know it. That is there. So consumers' choice should be informed. That is most important. That is part number one. And for that purpose, whatsoever government is doing, government focus are only two. Let me put it very, very clearly. One is that to create a level playing field in all perspectives. Secondly, incentivize to the extent possible where we can do within the country things also, because it has economic spillovers. Devi was mentioning that we should not make any barrier for the neighboring country, this country, that country. I agree with you that there should be, in the ideal market conditions, there should be no barrier at all. But when you realize that the country is being subject to certain predatory prices, then there is no level playing field. So it has to be protected in certain manner. CSR laboratories are coming up with technologies in a very, very big way. We know that. One of the projects, which is in IIT Chennai, one of the ARCI, the center is coming up with this fuel cells for the 50 kilowatt, and their assembly line is rolling up. So now there should be a finer balance that what the developments are taking place. Technologies are there in the country. Let me put it that way. But how these technologies can be translated into the market, that is again one of the most important area of work for any government has to look into. Because this is a public merit good and the public spending has to be there. When it comes to creating an ecosystem for innovation or research, this becomes a fulcrum of activity. That if you are developing some technology, you have shown that technology, whether there are barriers to make that technology on the ground, because this is public funded laboratory, or their PHEL has come up with a number of technologies. CSIR laboratories are doing very exceptionally well in many of the storage technologies. So what is the role which comes either for market or for government, that how to roll out these technologies for the day-to-day operation? And if somewhere, because global dynamics is not that clean as it looks, prices are deliberately many times are put down so that you can't make your contribution within the country also. So any of the barriers which are put just to create level playing field, not to discourage anyone. That is a fundamental point which I want to make it. But it should not be rhetoric that we keep on telling that chodo is sabko, leave at and open market will work. No, things does not work that way. Second, the role of government is the aggregation of demand in the different sectors. That is very important. Had government not rolled out the mobility policies, storage could not have come up to that stage which has come today, particularly for the mobile application. Similarly, if I quote in the renewable energy also, there are a number of studies which suggest that at present the storage is not required. Our grid has sufficient flexibility whereby we can meet the entire requirement for the grid. Whether I quote the NREL study, which was done by the US side, US NREL, or I quote the CEAGE study, which is the technological repository of information and knowledge for the grid matters in the country. They also say that for all practical purposes, you will require storage after 25, 26 only. But still, to create a market and aggregate the demand, Government of India has consciously started working on creating an ecosystem for storage in the renewables also, grid integration, as well as for the mobility application. And the indicators which are there is that the tenders which are being floated by SECI are very, very storage friendly, which gives a premium for storage technologies to be built in with the renewable energy system. At the same time, our wish and will for creating advanced chemistries and others, which is technology agnostic, again I'm repeating, is under the NITI Aayog's or DHI's program for this PLI for battery development, or the FAME scheme for that purpose. We are spending more than 10,000 crore rupees under the FAME scheme for different mobility applications. It directly or indirectly is helping to create a storage ecosystem in the country and incentivizing the same, both creating demand, aggregating demand, and thereafter just market to work on that. But there is requirement of a safeguard also. Always I have mentioned that, so that the development is neither skewed nor favoring some category of users, nor deceiving some, because the information asymmetry should be minimized as much as possible. That is another thing. Number of claims are being made about the technology. This technology will do this and that. On ground, is there any platform whereby one can justify that and just say that this is really something? We have been coming daily basis some of the information hydrogen that we have done this, we have done this. But when you start looking at it, we realize that no, still some time is there. It has to be done in a very, very systematic manner where country does not halt. We have been doing since last 15, 16 years on these things. But considered viewers that there is still some research and development and innovation ecosystem is required. So thank you. I thought that I shall just clear some of the air which I thought is needed here. And every aspect is important. Today's presentations were really marvelous because they touched different aspects. Tata Motor told the practical ground what they have faced. There are other presentations which have given different aspect of the storage technology. So that way, I think we are really moving in a direction. And for a country like India, it's very important that the momentum and pace remains intact, and we all contribute in a very positive manner. Thank you very much. And my sincere apologies, because I would have continued to listen it, but I have another meeting to just join that, and my sincere apologies for that. Thank you very much.
Thank you very much for joining, sir, and very insightful remarks. And now I'll just turn to Ms. Veronica Garcia. So you have heard, so Veronica, welcome, and you have heard, the different panelists present their solutions, and you also heard the three panelists before you touched on different points. Now, given that from what I have read and understand, Bitlumens is more in the off-grid space, if I may say, looking more at, so your scale of operations would be more to do with the mini grids particularly. So what opportunities do you see in terms of scaling storage solutions and the different types of storage solutions in those settings, and what linkage and opportunities do you see for expanding into the centralized connected space?
Yeah, so thank you very much for the invitation. It has very enlightening to see, all the presentations. I mean, I think from my experience and what we have seen so far is, I would say it's a combination of technologies that will really allow for these distributed energy resources to really scale. And storage is, of course, one of them. If we see, for instance, that the battery system will charge during off-peak times and discharge to the grid, even if it's a mini grid during peak times, this will be supporting, if it's a big grid, the expensive distribution transformer equipment, deferring the need to the distribution company, for instance, to add more infrastructure by peak shaving, right? Whenever you are connected, of course. And this will support the reliability as well of the distribution system to mitigate the impact of peak load on distribution transformer equipment. And of course, this will improve as well the power factor. Right, so from, I would say, a storage perspective, is extremely important to understand what are the possibilities, but also what are the market mechanisms that exist, right? So if, for instance, here in Europe, we would have, a lot of EVs are booming, and I have seen it in Delhi too. It's incredible. So then if you think of your battery at your home being one node that will feed the grid, and we all do that at the same time, how are these disruptions going to affect the grid system, right? So I think it's the storage system, but it's also the software that will be able to do balance and control, right? So we can reduce also the infrastructure that we will need to add into the grid. So I think this particular piece is important, and the market mechanisms that exist, right? Like for instance, if there exists real-time prices where you can have additional revenue, but really feed in the grid at certain points in time because you are not using the battery. This would be quite interesting. There are some other applications where you can, of course, do trading of energy in between parties, between nodes, and there is where I think the integration of IoT means smart devices with the blockchain will make a huge change because then you can get paid pretty much immediately without waiting, right? So I think all of these different applications, and I love the different use cases that Tata Power was explaining and what they have done on the ground, they have been doing. But of course, at the end of the day, it's a matter of cost, right? So I understand that, you know, one has to test and try and commercialize new technologies, but what is the cost of that? And I do believe that the Indian market is very sensitive when it comes to the different cost structures that exist. And we have faced one of, you know, those challenges because we want to bring the smart meter at prices that are really low enough for companies to be able to adopt, together with the software, of course. But if you see, for instance, the lithium ion batteries, we have reduced the cost massively. From 2010, we were at $1,100 per kilowatt hour, and then we are reducing towards $137 per kilowatt hour in 2020, and we expect to have 55% decrease by 2030. So we would really need batteries and storage systems that can compete with that. And so we have been in contact with a great company in Germany, for instance. They are called Kraftblock, where they are actually it's a thermal energy storage system that can be implemented for grid management purposes. And they have a very particular state-of-the-art process where they can store more than 200 megawatt hour energy. So, you know, this type of solutions, I believe they are going to enter slowly into the market. But the big question is how to commercialize it and how is storage added into the policy planning tools, right, for the power sector to really adopt that. So I do believe that policy and regulation and the different frameworks that exist will create a huge opportunity in the future if this is included, if storage is included in this type of policy planning.
Thank you, Veronica. And I'll take a couple of pointers from what you said about the intersection of policy planning and also the cost sensitivity of the Indian market to Dr. Pages. So, given that your technology, one would say that it is a direct competitor to a lithium-ion battery solutions and other different technology solutions which are also there. How do you see zinc gel technology evolving? Like right now, we talk about these price curves falling for lithium ion, as Veronica also pointed out. So, what kind of price curve flattening or reductions do you see for zinc gel technology, and thereby expanding its application portfolio?
Well, I would just say I'm not the expert in zinc gel batteries, but what I can tell you is that the minerals and the extraction of these minerals and the way they trade around the world make a huge difference when it comes to the pricing schemes that they have in each country, right? So if India has a free trade agreement with China and the Chinese are the main producers of vanadium, then you will have a very safe type of pricing reduction over time. But if you don't have these free trade agreements with Brazil, for instance, or South Africa, then things will change, right? For zinc, if you have the producers in India, I think this would be a huge advantage. And that's something that we personally, we want to see. So at the very beginning, we started the design and manufacturing of the smart meter here in Switzerland. And we are trying to move this into India, an Indian manufacturing type of company, because we just see that there is, a huge advantage since Switzerland doesn't have a free trade agreement with India. So then it would be very important to really reach and get into those price reductions that are needed to really commercialize and reach large scale.
Tejas, do you want to also touch upon some of
Yeah.
these?
So so there are two components, I would say. First is, of course, the cost, as Veronica mentioned, certainly important. But the other aspect is also the compatibility. So Dr. Kane know this really very well, that lithium has certain limitations with respect to charging speed, C rating, also operational expenses, because they have to be maintained at a certain temperature. And I think those points will also play a critical role in deciding what kind of storage is required for a particular application. So now, if you compare zinc gel, if we put zinc gel into both these aspects, certainly cost is going to be very competitive, because of all the raw materials that are readily available across the globe. And it's just, like I said, it's not just India, across the globe. They're non-toxic, and also they're in commodities. So price reduction is not going to be gradual. These materials are already commodities. So you can, for India, let's just say you can get it on India Mart, and the cost right away could be, it could be right away competing against the existing lithium prices. And with respect to performance parameters, I definitely vouch that there will be certain applications, such as in utility, where zinc gel will have a upper hand with respect to lithium.
Thank you. I'm also taking a look at the time. So out of the many questions that I still have to pose to the panel, I'll just pick one to Mr. Nilesh Kane, and then pass it on to Anirudh for the Q&A session. So Mr. Kane, one of the important things is, the storage opens up a lot of avenues for utilities in terms of new business models. And particularly, we in WRI are of the view that combining renewables and storage can help you, for instance, in retaining C&I consumers, folks who might be looking outside for open access, or even with their on-site solutions. So while you spoke about the pilots that Tata has carried out, are there discussions and possibly even pilots where you have tried out testing out new business models among C&I consumers?
Yeah, thank you for your question. We being in generation, transmission, and distribution, we are trying out all the applications. So I spoke about the pilots. We have tried applications like peak load management and ancillary services and all. So good news is that now ancillary services CERC in draft regulation they have added. So as a distribution utility, we have a requirement to take care of load management, peak load management. So for that business case and that pilot we have studied. We have carried out a very detailed study for Delhi and Mumbai. And in Mumbai, especially for generation, transmission, and distribution. And recently, you might be aware that there was an incidence of power failure in Mumbai. So to take care of such emergencies, also how much battery is required and how it is placed, where it is placed, So that study also we have carried out with the World Bank. And right now also we are doing one study in Mumbai to find out that. In addition to that, Mumbai has a competitive, distribution. There are 2-3, Adani and Tata Power are supplying, and a lot of competition is there. to acquire the customer. So customer is also very demanding. So to take care of, and the time of day tariff in Mumbai is very effective. So open access, taking captive generation and all. So customer is trying to optimize the bill. So behind the meter, the battery storage is a very good applications, especially in Mumbai, and we are trying out few customers in which we are planning to have a pilot case, and how where we can optimize the bill and how best we can use the battery. So that is something is also going on. And in addition to that, we are trying, the other chemistry like the zinc is one, because our experience what teaches us based on last 2 years experience, the auxiliary consumption for lithium ion battery is very high. It is in the range of around 3%, and let me tell you, for 10 megawatt battery storage, around 200 metric ton, the capacity of the air conditioning we are using. So huge auxiliary consumption is one challenge. In lithium ion battery itself, we can optimize the auxiliary consumption. So there is a huge scope, for the zinc batteries. They claim that they only require, the fans and very less auxiliary consumption and all. So we are trying, to balance out the battery storage solution for all our applications, based on the economic, based on the ramp rate, based on auxiliary consumption, and obviously the depth of discharge. So we are trying to balance out between the economics and our requirement for the various applications. The power quality management is another area, in which we are trying to use the battery, and reactive compensation we have successfully used in Delhi and across India to create the discipline in the grid. The reactive compensation, the utilities are paying crores of rupees the penalty for not maintaining for the drawal as well as for the pumping. So battery is playing a very important role. By simply changing the mode of inverter, you can use the battery for the reactive compensation. So there are a lot of business cases and a lot of avenues of the revenues from the battery storage, and we have already worked out many, and we are in the process to do that very systematically by doing the business system.
Thank you, Mr. Kane. And I realize that we need to leave some time for Q&A. So thank you to the panelists for taking time out, and really excellent points. And to summarize, if we need to look beyond lithium ion, the importance of R&D cannot be overstated. And at the same time, the interventions from policymakers and other stakeholders to help build the demand for these for the application of these new technologies, that is also significantly important. At the same time, from the discussion, it was also heartening to see the example of the industry academic collaboration that Dr. Kalai Silvi mentioned, the transfer of technology for chemicals. And last but not the least, given that having the geopolitics of this is also going to play a significant role. How much can we indigenize the supply chain is a key question to also consider as we look at these technologies beyond lithium ion. And at the same time, the same concept of geopolitics will play a role in creating FTAs and other relationships with countries that you spoke about. So in summary, a little bit of everything is how I would summarize this discussion. Anirudh, over to you for the Q&A. Maybe I request if panelists could stay on for 5 to 6 more minutes, we'll try to pick some of the questions and address them. Thank you so much.
Thanks, Deepak. Thanks for all the panelists for the detailed response. And there were few questions that were asked, which are answered mostly by the panel members. And some specific questions being directed to Dr. Saurabh and Dr. Tejas regarding the possible timeline of deployment. Timeline of deployment for their technologies, and what will be their bankability at this point. I have seen that you have answered the question, but it would be nice if you can share it with the audience.
Yeah, sure. So we just finished with this Zinc gel. We just finished our third-party validation of the core technology. So next piece would be to standardize the manufacturing and packaging of the battery. So it should take around 6 to 8, 9 months for that, and after that we'll run some field trials. So commercial deployment should be expected late 2022. I would say, for zinc shell.
Thanks, Dr. Tejas. Dr. Saurabh, your response.
Yeah,
regarding
sure.
your technology.
So concerning our hydrogen production system, so basically we are already in the stages of doing targeted commercial pilots. So we are starting very firstly, basically here in India because of the geography, here in Switzerland because of the geography region. But we are already in discussions with some big Indian players for starting with commercial pilots there in India, which are targeted starting next mid-year. And so our strategy is to do basically this industrial level pilots for varying application fields for the next 2 to 3 years, and then start the wider scale deployment. And concerning the bankability, so even now with the high prices, because we have not commercialized our solution on a mass scale, our solution is competitive for various niche applications. It's not that it's not bankable or not competitive, but to really compete with fossil fuels, basically to really reduce the price of green hydrogen production to the level which I just presented, to $1 to $2 per kilogram. For that, we need definitely mass commercialization of our technology, and this we are planning to achieve somewhere in 2024, 2025 and onwards.
Thanks for your answer, Dr. Saurabh. Tejas, another question for you is regarding the scalability of zinc gel batteries for grid-based applications or for large-scale storage in general. Has this been like in discussion or has it been sorted out? What's your response for this?
Yeah, absolutely. I mean, that's one of the major applications that we are targeting, because our batteries can actually go up to 5C charge and discharge, and that too without losing any life, having effect on any life cycles, because that's a major concern with respect to higher C ratings. Also, these batteries don't require thermal regulation, as in case Dr. Kale just explained. So our batteries are stable until 60 degrees Celsius, and we have tested this across. So and basis the application and locality, we can actually tweak the electrolyte composition and build a battery accordingly. So that kind of flexibility we definitely have. So utility is certainly an application that we are targeting.
Thanks, Dr. Tejas. This question is for Mr. Devi Prasad. There has been a lot of noise regarding gravity storage. Will this be a suitable alternative to pumped hydro system, or how do you see the potential for gravity storage in India?
So both the cases have similar challenges. That's the one comparison I can tell you. It requires the environmental clearance first, and it takes a long time for the build up, but the cost is really low. And gravity storage, yes, in European countries it has been used in many pilots, but in India we expect, like, yes, for grid applications it's have some future and there is a potential. It doesn't include only like pumped hydro is also a gravity storage, but that required actually the more clearance from environment department, environment, and also it have some aquatic clearance, so many other things. But other like concrete blocks or rail, like there are new concepts are coming. You have to take different terrains to the rails and you can release it. So everything is working on the gravity. So it has good potential for the grid applications. So this type of pilot should be encouraged under the new innovation from government. So we see that there is a potential.
Thanks, Mr. Devi. And this question is to Mr. Dr. Nilesh Kane regarding the market for lead acid, advanced lead acid batteries in India. Since you mentioned that it strikes a right balance between lithium and lead acid battery, just want to know your detailed comments on that.
Regarding advanced, lead acid battery, we have tested that battery and we have done some pilot also. It is very useful battery. I understand Exide was supposed to manufacture that battery, so something is held on right now. But I understand there are one more manufacturer is planning to manufacture that. So in time to come, by next year, advanced lead acid battery will be in the market.
Thanks, Mr. Nilesh. If Dr. N. Kalaiselvi is available, there is a question on how to take this all the lab scale, TRL scale activities into commercialization. Any details detailed response for that one.
Hello, can you just repeat the question?
Yes. Hello, ma'am. Is it audible?
Yeah, you're audible.
Yeah. So there are many research activities in the electrochemical space for battery technology. You mentioned various activities in Redox batteries taking place. And do you have any suggestions for getting these things from TRL to commercialization scale?
Yeah, TRL to commercialization.
Yeah.
TRL to commercialization is like this only. When we reach around more than TRL 6 or somewhere closer to 7, definitely the technology will be transferred to the industry. Then in their site, the technology will be validated, and this is how it will reach the society. And of course, we have a number of ways in which the technology could be transferred. And maybe we can transfer it as a technology, know-how could be given. Sometimes even the design could be shared. So these are the different ways in which we are transferring the in-house developed technologies as well as the know-how to different industries. And we see that, and we always handhold the industries till they start that particular production or whatever it may be, the activity for which the technology is transferred. And we see that the first batch of production happens in their site also. So this kind of a hand-holding, it becomes a part of the technology transfer, and we normally do it with any kind of an industry, be it a battery industry or a chemical industry or wherever we transfer our technologies.
Thanks, Dr. Kaliselvi. Just a kind of, if I can probe a little further, are there any planned demos in the coming near future?
Yeah, actually, we from CITRE itself, we will be coming up with our own 100 megawatt lithium battery production plant. So we have been already given 100 crore by CSIR, and it will be carried out in 2 phases. So within another 3 months' time, we will be coming up with the first stage production of 18650 cylindrical cells of lithium ion batteries. And maybe within another 12 to 15 months, we will be coming up with the 26650 cylindrical cells and prismatic cells of lithium ion batteries from our own Chennai center. So this is a 100 megawatt lithium battery production facility. And once this production is on, and if it is kick-started, so any industry can really just show their interest, and we are ready to handhold them even in that plant also. Right now, we are transferring the technology on materials as well as how to make cells. So how to make cells, we will be able to handhold the industries by using the facility which is now upcoming.
Thanks. Thanks for the detailed response. I guess we have covered most of the questions in this regard. Once again, on behalf of WRI-India, I thank all of you panel members and the presenters for participating this evening. Thanks a lot. For our audience, most of the questions have been answered, and this will be compiled and sent to your list. So the link for the recorded webinar will also be made available in our website. Thank you all for participating. Thank you.
Thanks.
Thanks.
Thank you.
Thank you, everyone.